to the power p by 2 equals a into alpha is a constant. So, alpha to the power p will also be a constant, and then pi to the power p by 2, and then I have delta sigma to the power p by 2. Okay. So, I will have delta sigma to the power p by 2, and now I do the integration from ai to ac, right, and we are starting from a no cycle. So, we starting when we start applying the stress, and to the number of cycles which will lead to a crack length of failure, and dn will come from this denominator side to that side, right. So, I have no function of n here. So, it simply becomes nf minus 0, which is nf, right, and here I have function of a. So, that will become a to the power minus p by 2. So, that will become a to the power minus p by 2 plus 1 divided by minus p by 2 plus 1, and this will go from AC to AI, right, and that will be equal to a into alpha to the power p pi to the power p by 2 delta sigma to the power p by 2 nf, right. Okay. And then if we put the value of AC and AI, it becomes AF to the power minus p by 2 plus 1 minus AI to the power minus p by 2 plus 1 divided by minus p by 2 plus 1, and into I can take all these things. So, A alpha to the power p pi to the power p by 2 delta sigma to the power p by 2 will be equal to nf. Okay. And AF I have already calculated from this. So, I can just plug it in there, or if you have a numerical problem, you can calculate the value of AC, and that you can put it there. AI will be given, because we always know in the system if we are doing a test in the laboratory, or if we are trying to find out for a structural component, we know the value of AI from ultrasonic testing or some other non-destructive testing, and from the AF we can calculate from the fracture toughness of the material, and rest of the things we know from Paris law. And once we have Paris law, we can calculate that after how many number of cycles my material will fail. Okay. So, this is the importance of Paris law, and in nutshell we can actually, so the problem is that sometimes this alpha value is a function of crack length itself, because that is a geometry factor and you have to take care of that. So, if that happens to be the case, then this alpha will also come in here in the integration. So, you will have alpha to the power p. So, this part will be coming here. Okay. So, depending upon that, but that part is very simple. If you once know that if this is a function of a, then of course integration is not very hard. So, this is the basic of finding out that how do you find out the number of cycles for failure. If you know the initial condition and if you know the final condition, you can calculate it from the materials property, and you can find out if your structure is going to hold certain number of cycles or not. Okay. So, we conclude the lecture today here, and we will talk about more on fatigue in the next week. Thank you.